I made a reference to Powers. It's Austin Powers that talked about lasers. Remember he put the lasers on the shark? Yeah. And that's what I think I'm going to have to do on my UAV, UAS, because they just started coming out in earnest. It was actually on a GEER reconnaissance. Kevin Franke from BYU used this to actually do a survey with the photographs of a port facility that had lateral spreading. He was able to capture some very good deformation of that from a distance of about 100 feet off the ground and capture some really good information. That's in the latest report on that Chilean earthquake that was just posted. But they also were out there for the South Napa earthquake. And so, for example, you know, I've learned from my military background, the first thing to do is get up in the air. And so now you have air, you know, you have Google Earth and you have remote sensing, but still you want to get up in the air. And so when the Napa earthquake hit and the California Highway Patrol offered the opportunity for us to go up in the helicopter and fly over the area, I said yes. And so actually a geologist from the USGS and I from GEER went up with this helicopter to survey the area. You just see things from the air at 500 feet that you don't see elsewhere. Having surface fault rupture is one of the key issues, and having a UAV basically fly over the fault, you're able to see things and get oriented. And so this is the, you can see the fault, and it's going a little too fast here, and then it's right there, and it comes right through here. The fault cuts right through there. And so you get to the site. Everyone went to the school where the fault just hit. That's where this movie started. But you're able to basically get up and kind of fly around that area and get a better sense of where the fault is coming through the ground right over there. And so it's just, there's something that happens when you're up at that distance and you're able to fly down, come up. It's just incredible. And so everyone has run out, Peer, GEER, because these things only cost about $1,000, and that's with a fairly good camera unit and with a device that when it loses its power, just before it actually flies back to where you started, and so you don't lose the device that you put out there. So I see it's going to be a revolution, but I also think it's going to be an issue because of all the things that Scott talked about. The last thing to talk about, first thing is always safety, but the last thing is just as important, not just important, but it's another important element, is in the end you collect all this data and there's a lot of excitement, there's a lot of energy in doing that, but in the end we need to get to actually integrating all this data, and I think Rob Kane kind of showed you how you can do that on the fly, but there'll always be the need to essentially take observations from different people. Like I said, for example, along the Kojali earthquake and the fault there in the Northern Anatolian Fault, there were different measurements, and it was by looking at the time stamping and such to make sense that, hey, we not only had redundant measurements, but we had them through time, so we were able to get afterslip, which is something that's very important to seismologists and engineering geologists in terms of looking at faulting. And so pulling all this together is critical. The report phase is a very important phase. It's done at the end, but it's not the least important. In fact, I always try to remember that there really are 4 phases. There are 4 phases to reconnaissance. The minute the event occurs and you realize you're going to be going out, there's the planning phase. And then there's the actual field reconnaissance where you execute. Of course, you have to make changes on the fly and be flexible. Then there's preparing that report. But very importantly, if it's a good report and it was the right kind of event to go to, there's going to be some follow-on research that then is going to advance the practice. And we do that through papers, obviously. And so data sharing integration is critical, and the reporting element is critical. Really, the main thing, if you go to the GEER website, is the GEER web reports. The Oso landslide report was downloaded probably thousands of times, and it's an incredible resource that's being used by people. The Chilean earthquake in 2010, that's still the definitive report on the observations of that earthquake. But then we can take some of the better material and we can put that in the archival journals, such as the Earthquake Spectra and the International Journal of Geoengineering Case Histories. You know, a lot of this is synthesizing and interpreting our field observations. And we talked about Google Earth and graphics and identifying of all the facts. It's always better to take too many photographs and then just hone them down to the most important. One of the things that we've noticed is in the early days, I had a digital photograph, a 1990 camera that took photographs that were maybe 90 kilobytes in size, and they were poor resolution. So I'm still glad I had my slide camera at 35 millimeter. Then we got to a point where we started getting to 2 to 4 megabytes. Now there's some cameras out there that they were taking pictures that were 12 to 16 megabytes each. You can do that, but it's almost overwhelming the system. And you can't post those, you can't embed those in KMLs. So everyone has a different take on this. You can always obviously take a high resolution picture and make it less, and you can't do it the other way. But around 2 to 4 seems to be optimum for a lot of things we're looking at. I know, Rob, do you have an opinion on that? So I found people who took photographs at too high a resolution had to spend time either uploading large files or downsizing them. And so obviously if you have a good camera, you can download it to an accuracy that's reasonable. And in most cases, if you can blow up a photograph and get really good detail when it's 10 by 16 or something like that, you're fine. So just realize that in the end, you're going to be sharing this information. So you're either going to take the highest quality pictures and then you're going to downgrade them to be able to embed them in a KMZ file, or you're going to have to do the linkage that Rob's talking about. Track logs, he's talked about all those things for sharing. So the goal for web reports is rapid report, so we get out the key observations to the community in a responsible way. So we want to be accurate. It's better to not say something than to say something wrong. And it's important, though, to get it out in a timely fashion. And there's always a push toward the GEER community to want to have everything be 100% correct. And you know, that's why we've kind of broke it down and said, you know, we're getting a little slow sometimes on these version 1 reports. So we're going to have a quick report. It's whatever you have available that you can responsibly put out. Initial photographs, initial assessments, clearly no hypotheses on what's going on within 1 to 3 weeks. I think we have a responsibility to our funding agency, we have a responsibility to the community to at least get an initial assessment out. It can be a 25-page report, it can be a very short report through the website that just says, we've gone, this is the initial observations, here's some initial photographs, here's some initial Google Earth images with track logs. And then version 1, and we call it version 1 because we know there's going to be a version 2 for a comprehensive earthquake such as Haiti, Chile, and New Zealand. All of them had a version 1 report that came out within 4 to 8 weeks after the event, and then with additional information, with Rob Kane going there and measuring shear wave velocities and doing LiDAR surveys and other people following up, and us having the chance to collect our thoughts, we come up with a version 2 report. I haven't seen a version 3 report, but there's no reason why you couldn't do that. One of the key things is, you know, people start collecting information, and then you start realizing that there's certain people that have the aptitude and the training to say, okay, you know what, I'll write the chapter on liquefaction. I'll write the chapter on landslides. It's very important early in the game to start getting sub-team leaders so the problem for the team doesn't become the team leader's problem to put everything together, and that you have responsible people you can count on. Okay, you're putting this report together, this chapter, this chapter, this chapter, you break that all apart. And having done that for the South Napa earthquake, it was really, the graduate students really stepped up because all of my colleagues were out of town when this earthquake hit. So I was the only one in there. So the graduate students essentially wrote these chapters and pulled it together very nicely. So dividing the work is critical. One of the things we've done, we started off as geotechnical earthquake engineering reconnaissance. And we realized, actually it was 9/11 and some of the work that was done by David Frost after that event in terms of capturing the blast effects, and I mean not the blast, but the damage effects of that. And then it was Katrina, where we realized they were doing things with dumpy levels and normal surveying techniques. And I said, you got to get Rob Kane out there with his LiDAR to capture these breaches before that data is lost. And so we realized if you can capture earthquake effects, you can capture tsunami effects and surge effects and Hurricane Sandy and Oso landslide. And so we've decided we've evolved to where now we are geotechnical extreme events reconnaissance. And so we try to see the report as context, demand, effects, and tools. And this is laid out in the GEER reconnaissance guidance document, version 4 that Rob talked about. First is the context. I think it's very important for anyone reading the report to understand the context of your observations in your report. What are some of the societal setting issues? Obviously, the geologic setting. If it's an earthquake, the seismological setting. If it's a storm event, rain-induced landslide, the meteorological aspects, and understanding if there's scale effects, for example, and multi-events. In New Zealand, we had the earthquakes that caused ground settlement, and then a couple years later, we had a flood event that would not have been as damaging as it was, except that the ground had moved down. So we're starting to look at multi-hazards effects and interrelationships. Then there's the demand. And so the idea is to collect that information and report on that information that categorizes the demand. The wind, the rainfall. So they talked about the Oso landslide, why it was so important to get that rainfall patterns in the area. Obviously, if you're looking at the effects of surface fault rupture on structures, you need to have very good documentation of the surface fault rupture and the actual tectonic displacement around the surface faulting. Ground shaking, that's why one of the most important things are there ground motion instruments that have recorded the ground shaking? If not, we're never going to be able to take that to the next level and make it a well-documented case history. Landslides and other things. Then we focus on the effects. And so the effects are things like scour effects, such as an erosion effect, such as the levees in Katrina, the impacts of the landslides and the flows, the impacts on infrastructure, local amplification effects, liquefaction effects, and including lateral spreading, understanding earth and waste structures, dams, levees, and landfills. Ports and harbors always tend to be a chapter in our earthquake reports. Transportation systems, other lifeline systems. Very importantly, excellent performance of infrastructure in areas that were strongly shaken. Obviously, if you're away from the areas that are strongly shaken, if your area away from the landslide, it's not as important. But to have, very intense shaking. The South Napa earthquake, one of the big things there is that's an area that's had liquefaction issues in 1906. It even had liquefaction issues for the Southern Hayward earthquake. So we went there, we went to the mapped areas that were higher liquefaction potential, and we didn't see any liquefaction. And we looked, and we looked, and we have a lot of track logs that say everywhere we went, with a lot of photographs of no damage, because now we have an opportunity to go to a place that was strongly shaken, not with only 1 or 2 or 3 or 4 significant pulses, so it wasn't long in duration, but there were some very intense ground motions, 0.2, 0.3, 0.4 G, and these sites did not express surface manifestations of liquefaction. So that's that null space that Rob was talking about that's important. And then last is we always look at innovation and tools as being something to bring in. There's typically an appendices or there's chapters in the GEER report that talk about using something like UAVs, using LiDAR, using geophysical techniques. The dynamic cone penetration device, which Scott Olson was doing in Chile and Haiti, is a very nice device. But for example, in New Zealand, the Swedish weight sounding has actually correlated very nicely to CPT. And it's something that a person can do fairly easily. One of the things that I always do, having written several of these reports, I still go back, and so after that South Napa earthquake hit, I go back and look at other reports and just look at where they're good and where they're not good, and the whole idea is to make it better. In fact, Ellen really raised the bar. If you look at, Rob's been raising the bar with his Google Earth and bringing that in, but then Ellen did a phenomenal job on Haiti, so that kind of set the bar for David Frost and I, and we had to obviously try to do better for the Chile earthquake. And better is not more comprehensive that takes 6 months. Better is getting out a report quickly that actual and gives the community the initial information they need. Because you have people out there that are going to use that information and go forward with it if it's a good report. You know, the early GEER reports were actually just photographs with long captions. There was a little bit of introduction. It was just photographs and captions. And I still think the heart of it should be photographs, captions, and Google Earth images. But everything is geolocated. And I just reviewed a report, and I sent it back to them and said, please add the GPS coordinates, because 10 years from now, if someone wants to come back to the site, they need the GPS coordinates. And so every photograph, every item should have GPS coordinates in the caption, as well as the date and time. It's always useful, as Rob mentioned, to look at pre and post photographs and put those in there. So pre and post Google images. There's phenomenal pictures before the 4 September Darfield earthquake of 2010. Then there's photographs actually just before the 22 February 2011 earthquake. And then they actually have Google Earth images about 4 days after that earthquake, where you can really see sand boils and see eject all over the place. You know where there was significant ground failure and where there wasn't significant ground failure. And it's good to bring in the geology, the topography. You start to get damage statistics. These are 2 damage statistics of destroyed buildings in Haiti. And so that layering information is incredibly useful. And then the GEER report wants to take in those follow-up phases. We don't do this in the advanced phase. We typically don't do this in the main body. But we typically will have a follow-on phase where we pull in this information, such as the SASW measurements. Most reports come out as a report. But for example, because of the limitations of getting people to Tohoku, and then also just realizing how big an earthquake that was and how it affected different things, it became very quick, useful to realize we should have phased reporting. And so again, if we had waited to pull all that information together, that report would have gone out probably 6 to 12 months after the event. By encouraging people to put quick reports out as they came back, Team 1, Team 2, Team 3, the community started seeing this, and then also, in fact, it helped National Science Foundation say we need to have a special request for proposal to essentially get proposals for both this earthquake and the New Zealand earthquake. These kinds of documents help motivate people to fund follow-on research and reconnaissance. Everything is Google Earth for sharing things among people. When I was in Chile, I basically said, before you go to bed, send me your KMZ file so I know where you've been and where you haven't been. The other nice thing I found in Chile is we had very difficult phone coverage because of some of the mountainous terrain. Texting is a great way of going, because you can text GPS coordinates to people and say, go to this location. I've just talked to somebody who knows somebody at the University of Chile who said that there's a tailings dam that has failed. You're up in that area, please go look at it. And very terse language. So you're very impolite when you text, but you can apologize for that later when you get back. The whole embedding the photographs, we've had some discussions on the GEER steering committee. Should we continue to go with the reports the way we're going, or should we start having virtual reports? And I think a lot of that comes down to the next team leader and the community saying, how best is it to display this information? This is not a top-down organization. This is you as geotechnical engineers, geologists, deciding how best to conduct this. And when a team leader is selected and the team is assembled and they go out and do things, the rest of us step back. Our job is to help make some decisions on whether we should go and what the scale should be. But once it's your project, it's your thing to do and do well. Your names are going on the reports. My name's not associated with. None of the people on the steering committee are associated with it. It's yours. I think that more and more we see the opportunity of continuing to collect information. This is the earthquakes over in Chile, continuing to dialogue with our Chilean research partners, get data that we didn't have in the initial report, some actual initial boring logs, get some additional survey done, collect that follow-up information, and that's about the time when all of a sudden there's a call for papers, and Earthquake Spectra is a very good place for us to publish our work and have it there, 100 years from now in the archival literature. And then for non-earthquake events, the International Journal of Geoengineering Case History is very useful. So for example, in the Chile earthquake, I mean, we had pictures of this bridge and we had some observations, but we didn't have the detail. Now we had the building plan, the bridge plans, we had the pier numbers. Professor Verdugo had actually done a survey, or he was aware of a survey being done by the highway department. So that this kind of data is added and enriches what we have. And so the actual journal article is a step beyond what we've had in the GEER report. But it wouldn't have been possible without those photographs and without those observations in the first place. Same thing in Haiti is, collecting all these damage statistics, the topography, the geology, and putting all that together is something that it was motivated by the journal article. And then one of the nice things about this Journal of Geoengineering Case History, if you're not familiar with it, is one, it's peer-reviewed. It has the magic number where it's searchable, and so it's just like any other journal in that sense. It's got a good editorial board, good review process. It's a very reputable journal. The thing about it is it can be done quickly because it's virtual, and in fact they don't wait for an issue to get compiled and publish the September issue. As soon as a journal article is ready, it gets posted in that issue, and then another journal article comes up. And so you have the fastest way of going from writing the article to actually getting it out there for people to use. The other neat thing about it is instead of having a plot that just has data, you actually put the Excel file. The purpose behind this case history journal was kind of in the honor of Ralph Peck. He was the first issue he was honored, is we need to share data. And not enough consultants are writing papers that are going to create the case histories that are going to move the academics into the right direction. So one way of getting consultants to write papers is to make it easier to write. So you don't have to do a final analysis and explain everything. The idea is an experiment was done. An excavation was dug, a landslide occurred, mine subsidence had some adverse effects. Collecting that information. I've done experiments in the laboratory and I've traveled around the world doing observations from earthquakes. When I do a test in the centrifuge, I have control. I know what day I'm going to spin, how I'm going to shake it. I have all these measurement devices. Obviously, it takes skill for you and the PhD student to do that experiment. But this is an experiment with no warning, done by nature, and you're just tossed into the ground and you have to figure it out. So I see tremendous value in academic to be able to do very good reconnaissance and collect that hard data that then becomes the benchmark for a case history. And so I encourage you, especially those who are consultants, if you've got a really good project with a lot of really good data and you can share that data, don't stick it away where it's never going to see the light, it's never going to make a difference, but put it out in this journal and get that data out there, and people will start using that data and will advance the profession. So achieving our goals, this is actually a screenshot from the GEER website, and it talks about our 8 primary goals. Well, much of it is documenting the geotechnical engineering and geologic effects from extreme events, disseminating reports timely and accurate, post-event web-based reports, promoting standardization of measurement and reporting so that we all know what we're doing. The bottom line is if we do not publish our observations, we can't achieve our primary goals. Thank you. A little bit of preaching at the end, and I apologize for that, but then I don't, because I'm thinking about the last time we gave this was in Oakland. Ellen Rathje gave this, and she's a phenomenal person on the steering committee, because that's her first and second and last question is, when is the report coming out? And it's critical that we put things out accurately, but also in a timely manner so that we can make these changes.